All right, guys, here we go. In the last video, the first 9 problems, we were going from a single logarithm and then expanding it out, right? Now we're just going in the opposite direction, that's all. So, yeah, easy. And, the thing that allows us to do this is that the log bases are the same. Those have to match up for us to make this kind of move. And if it doesn't match up, then maybe you can use a change of base, which we'll learn about next. But yeah, right now we're just combining because the logs are the same. Yeah. So here's number 10. I've got a log base 2 of 5 plus 3 log base 2 of x. Now, the first thing I want to do is take care of any of these numbers out in the front and change those to exponents inside my log. So that's going to look like this. Log base 2 of 5 stays the same. This is log base 2 of x to the third. You're just doing the opposite, right? Think about back to your rules, yeah. If I have something that has a number in the front, I can go back in this direction to change it to a power instead inside the log. That's if I'm trying to get a single log, right? I'm trying to combine it to one log. Where was I? Oh, I think I deleted by accident. Okay, so now I have the sum of two logs. I can convert that to a multiplication of it. So this is log base 2 of 5 times x cubed, or in other words, 5x cubed. Okay, so that's also nice. Yeah, to be able to go to one single concise log. All right, that's number 10. And you notice a pattern here, yeah? Basically, what order we're going to do things in, we're going to take care of the exponents and then do the addition and subtraction. Addition and subtraction you can kind of do in one step. So that makes these kind of all pretty easy, honestly. All right, I'm gonna just look at this here and go ahead and do my work. So first thing I'm gonna do is bring any exponents I can inside, right? So this is gonna be log base 7 of x to the 5th, that stays the same, minus 4 log base 7. Okay, but I don't want the 4 anymore, actually. I want to take that 4 as an exponent, right? So it's x squared to the 4th power. So that's log base 7 of x to the 5th minus log base 7. X squared to the 4th, using rules of exponents, that's just x to the 8th, right? 2 times 4. Okay, so now I got a difference of two logs. Difference of two logs we write as a fraction, a log of the fraction. So this is log base 7 of top number over the bottom number. Oh, but look, they're both powers of x. X to the 5th over x to the 8th. We can actually simplify that, can't we? Yeah, so that's log base 7 of x to the negative 3. Because I get 3 more on the bottom, so that's... All right, think about it like this. If you want an extra step here, this is canceled 5 of the x's, right? So that's 3 left over in the bottom, 1 over x to the 3rd, which is just x to the negative 3. Okay, so I got log base 7, x to the negative 3 in the end. That's what you end up with. Okay, so that's number 11. Okay, that's why, how come things, they go good? Okay, let's go to number 12. Okay, 1/3 natural log of 6 minus 1/3 natural log of 2. Okay, notice, again, same logs, right? All natural logs. We said first thing we want to typically do is take care of the powers. So we do that. What I mean by that is there's a multiply in the front that becomes a power, right? So this is natural log of 6 to the 1/3 power minus natural log of 2 to the 1/3 power. Okay, I see what's going on here. So next, I got two things being subtracted, right? So I can rewrite them as a fraction. This is a natural log of those things divided by each other. 6 to the 1/3 over 2 to the 1/3. Okay, but if I've got the same power on top and bottom, then you could also rewrite this as natural log of 6 over 2 to that 1/3 power, right? Think about it this way. So if I have like a fraction like 4/3, right, and I square it, what is that? That's the same as 4 squared over 3 squared, right? But these can go in either direction. I could go from here 4 squared over 3 squared, and I can change it back to 4 over 3 squared. And so that's what I just did just now. I would change 6 to the 1/3 over 2 to the 1/3 to 6 over 2 to the 1/3. Okay, so that's just kind of just basic simplification of numbers. So that's ln of 6 divided by 2, though, is just 3, right? So that's 3 to the 1/3 power, natural log of 3 to the 1/3 power. And that's it. That's as far as we can go. But notice, nice and clean. Nice, simple, single number. Okay, that's 12. Okay. Here we go, 13. Oh, okay, 13. This one looks easy. This one looks super easy. I think I can do this one step. So I got single digit numbers, yeah? Whether it's single digit or double digit, that's not important, but just numbers. Maybe this might take 2 steps actually. Natural log of 5, natural log of 3, natural log of 2. Those are all positive, right? And then 1 negative. Well, there's no powers to worry about. So I'm going to jump straight to division. This is natural log of 5 times 3. I'm saying multiplication and division. Yeah? 5 times 3 times 2. And on the bottom, it's 7. You see that? Right? Plus becomes multiply, right? Minus becomes division, but all inside of a log. Okay, so what is that? Well, that's natural log of 5 times 3 is 15 times 2 is 30. And 7 is just 7. So log of 30 over 7. So it took me 2 steps because I had to actually multiply those numbers out. But turns out 13 was easy, as I suspected just looking at that thing. 14 doesn't look like much harder either. Oh no, we do have powers this time. So I'm gonna go ahead and do that first step and just take this 1/2 as a power and this 1/3 as a power. Okay. So this is gonna be log of x to the half minus log y plus log z minus log w to the 1/3 power. Oops. There we go. Okay, now looking at this thing, I got, this is a positive value, right? Positive in the front, I mean. Like a positive log, right? This is a negative log, positive and negative. So the positives get multiplied together. The negatives go on the denominator multiplied together. Because when you divide by one thing and then divide by another thing, they end up just being in the denominator multiplied by each other. So what I mean by that is it's going to look like this. Log of x to the half power times, so this is a positive one, right? This is another positive one, times z. The bottom, this is a minus, so that's going to be the y on the bottom. This is a minus, so that's a w to the 1/3 on the bottom. We're done. Yeah, it's done already. this log looks like it's kind of misplaced. It should be log right there in the middle of that thing. Yeah. This is the common log, log base 10, since it's not explicitly stated what it is. Okay. You guys getting a hang of these things? I can't hear your response, so let's see if that's me. So yes. If not, then email me. Okay, 15. All right, this thing is starting to look a little more ugly, but you know, same procedure. I'm gonna go ahead and do that first step here. This should be an exponent, that should be an exponent, that should be an exponent. So I'm gonna write it that way. Looks like I'm gonna need some more space here. So let me just move 15 over. This is log base 4 of x squared to the third power. Right? The x squared is to the third power. Minus log base 4 x to the negative third to the fourth power. The negative x to the negative third is raised to the fourth power. Plus log base 4 of x to the second power. Yeah, just took care of those exponents. Okay, now let's actually perform those exponents. So that's equal to log base 4 of x to the sixth minus log base 4 of x to the negative 7 plus log base 4 of x squared. Okay, now let's go ahead and do addition and subtraction. Addition, remember, if I'm combining to a single log, becomes multiplication, and subtraction becomes division. So it's log base 4 of x to the sixth up top, x squared also up top, and x to the negative 7 down bottom. Okay, but a negative exponent in a fraction just means you flip where it is, right, and change the sign. So this is going to be x to the 7th up top. So this is log base 4 of x to the 6th times x squared times x to the 7th over 1 if you like, but the over 1 is not necessary. So let's just leave it like that. And then now last step is just combine those powers. X to the 6th times x to the squared times x to the 7th. Add the exponents up. 6 plus 2 is 8. Plus 7 is 15. So in the end, I have this nice, concise form. It's just log base 4 of x to the 15th. I just wrote it in an unnecessarily convoluted way. Yeah, but you know, when I say that, sometimes that's what happens in real life. Like, right? When you're trying to solve something for real, or you're trying to like prove something, sometimes you have these long convoluted forms, and so you end up having to simplify them, and then sometimes they do really simplify very nicely like that. Okay, 16. Yeah, and you know, part of things simplifying nicely like that is like just smart design of the function itself, right? Smart choice for what they should do, but also like I feel like it's also just like this magic in the universe. Okay, here we go. You're doing the exponents. Exponents, right? So this is log x to the third minus log y to the 7th plus log x squared plus 7 to the 1/3 power. Okay, and then now let's take care of the addition and subtraction, changing that to multiplication of a single log. So this is log of x cubed times x squared plus 7 to the 1/3. And the bottom is the y to the 7th. And oops, looks like I already did the whole question. Didn't mean to just do it in one fell swoop like that. But I wanted to write my answer in red because that's what I've been doing. So I'm just going to copy the exact same answer. And as I'm doing that, I'm looking, is there anything that I could have done different? I guess I could write this as a cubed root if I want, but that's not really any nicer. So I'm just going to leave it like that. Just copied it down because I wanted it to be red. Okay. Well, I was not expecting 16 to be that easy. Okay, 17. Usually the questions get like longer as you go, as you progress, right? Okay, 17, looking for powers here. Do I see any powers? I do not. I do not. There's no numbers in front, yeah? So I'm gonna jump straight to dealing with the addition and subtraction. Anything that's positive, there, let's color coordinate. Anything that's positive, gonna go in the numerator. And everything that's negative is gonna go in the denominator of my inside of the log function, right? So this is ln of the blue on the top, x. When I say blue, you're not including the ln part, because that's the whole point, was to get rid of that, right? So we have one single one. And the red is in the bottom, so x minus 10 to x squared plus 3. Okay, I see. Okay, so essentially you're finished, but you know, maybe something nice happens if you multiply this out. Let me just try to look at this though for a second. I don't think so, actually. No, I don't think so. Yeah. So let's just see what we got. Actually, it's nice to leave it in factored form. So for a second I was thinking, should I multiply these guys out and then just expand the whole thing? But what's going to happen there? It's not going to get me anywhere really. I'm going to have some x cubed terms, but I guess just expand it out. But I think the factored form is better because you see more information. Right? And you can see if anything should cancel because it's already factored. So number 17 turned out to be even easier than number 16. And now I really feel like I should copy that thing in red because I did it in 16, yeah. But I'm getting lazier as I progress, so I'm not going to do it. Okay, number 18. Last one. Let's see, you got any powers this time? Yes, we do. This is a power. This is a power. I mean, it's a multiplier that becomes a power, right? Okay, so let's do that. It's going to be ln of x squared plus ln of x squared minus 9 to the 1/2 minus ln of x squared plus 4 to the 1/2. You know, this idea of highlighting is a good idea. I should have been doing this for the whole time. Positive up top, positive up top, negative down bottom. Here, I'll do it even better. Positive up top, positive up top. That's what goes up top, right? And negative down bottom. So the result then is going to be this. Just in case I finish already, I might change it to red now. It's going to be x squared minus 9 to the 1/2 power. And then the bottom, it's x squared plus 4 to the 1/2 power. Can I do anything nice with this? Can I take a square root of x squared minus 9 nicely? No. Can I take a square root of x squared plus 4 nicely? No. So that looks like it's as far as I'm gonna go. Yeah. A good thing I switched to red, because that's my answer already. All right, guys. Done.